Hello everyone, in this video I'll be explaining you the problem minimum number of pushes to type word to. So you're given a string S, a string word containing lowercase English letters. Telephone keypads have keys mapped to distinct collection of lowercase English letters which can be used to form words by pushing them. For example, the key 2 is mapped to ABC. We need to push the key one time to type A, two time to type B, and three time to type C. It is allowed to remap the keys number 2 to 9 to distinct collection of letters. We can do a remapping. Okay. The keys can be remapped to any amount of letters, but each letter must be remapped to only exactly one key. You need to find the minimum number of times the key will be pushed to type the string word. Okay, return the minimum number of pushes needed to type word after remapping the key. An example of remapping, letters on the keyboard below, uh, it's given below, and it's a general, keypad pattern. So one star hash and zero don't map to any letters. So um, in the I button, we'll be getting the uh, link to the previous question. So this is just s- exactly same question as previous one, but in this case, the only thing is the word is not distinct. Okay, we can have same characters in the word multiple times. So yeah, uh, only the that is changed. So you'll have to watch that video and please watch that video and come back because in that I have explained deeply like how we are, you know, mapping the characters. So now let's focus on this one. So it's a minimum number of pushes to type string 2. So the question is exactly same as the previous question. So please watch that video. So again, let me just tell on high level. So we have a keypad phone. So here we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 0 here, star, hash. In the question they've said this 1, star, 0 and hash should not contain characters, right? Yeah. And the remaining 8 places we have, right? These 8 places will have characters. Now we'll have to do a mapping in such a way that these 8 characters, these 8 cells is filled with characters. So in the previous video, since word was, you know, distinct string, so it was very easy. We had to just, place starting 8 characters into, these 8 cells. Then the other 8 characters was placing at the second position of every cells. Okay. And the other 8 characters was placing at the third position. Similarly, we are placing the remaining 2 characters at the fourth position because in English we have just 26 lowercase letters. Capital letters are not included here, only just lowercase. So, uh, but here word may contain multiple characters same time. I mean, same multiple characters. Same characters can contain multiple times. So how do we solve this now? Is the question. Let's take one example. We have A, B, C, D, E. Same thing again. So we have A, B, C, D, E. So if we want to, place in the keypad phone, so the word is A, B, C, D, E. What we'll do is we'll just place A here, B at this position, C at this position, D, E. Okay. And if we have done this thing now, in order to, uh, print this ABCDE, how many pushes are required? So if you push, uh, 2, key 2, if you push one time, A will be displayed, right? Similarly, key 3, if you push one time, B will be displayed. I mean, key 4, if you push one time, C will be displayed. So in this case, the answer is 5. Reason being, every characters are displayed across, cells, and they are, you know, at the first position. Now let's understand the other example. So the word is now XYZ, 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 XYZ. Okay, 4 times. We have XYZ, 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 and XYZ. So what I'll do is I'll first make sure what is the frequency of X. So my character is X, it has occurred 4 times. 1, 2, 3, 4. Character is Y, frequency is 4 times. 1, 2, 3, 4. Character is Z, and it has occurred again 4 times. 1, 2, 3, 4. So in this case again, if I try to now make, mapping on the keypad. So again, one we have 0, star, hash, number 2, 3, 4, 5, 6, 7, 8, 9. So we have just 3 distinct characters in this case, and their frequency is also, same, which is 4. So I'll make sure I'll place X here, Y here, and Z here. So which means, in order to display X, just one push is required. Similarly with, Y and Z. So now if you try to make this character, what we'll do is, I'll take one more, mapping. We can say this way: character to pushes. So character is X, we have to push one time in order to display. Character Y, again one time. Character Z, one time you'll have to push. So in order to display this, one time you'll have to push. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So your answer is 12. So 12 pushes are required minimum, and in order to display the word. We could have done this way also. Um, just place XYZ in the same button. So, but here the pushes required will be different. So in order to display X, you'll have to push one time, but in order to display Y, you will have to push 2 times. And in order to display Z, you'll have to push 3 times. And now what will happen is, here one time push, here 2 time push, here 3 time push. So answer will be 6 into 4, which is 24. but 24 is greater than these 12, so 12 is minimum. So we are asked to, display minimum. So let's see the third example now. Third example will make something clear. So A is 2 times, B is 2 times, C is 2 times, D is 2 times, E, F, G is also 2 times, H is also 2 times, I is like 6 times, right? So what we should do now? Mm, Again, I'll take same thing, character with frequency. A has occurred 2 times, B has occurred 2 times, C has occurred 2 times, D, E, F, G, H, and I we have 2 times, 2 times, 2 times, 2, 2, and then 6 times. Now, if you see these characters, how many characters there? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 characters. And if we have, keypad phone, so if you try to place these 8 characters, these 8 characters across the, board, let's say A, B, C, D, E, F, G, H, and I remaining with. So I will be placing at this position, let's say. This will give you not the optimal solution. The reason being, since I has occurred, 6 times, what we'll try to do is we'll try to make sure this I should be placed in such a way that it has to be pushed minimum times. So so first thing first I'll see the frequency of the character. The character which has occurred more times, uh, that character I'll try to, place in the uh, keyboard phone first. The reason being, since that character has occurred more times, so we have to reduce its, pushing the key. So when we reduce the pushing of the key, definitely answer is going to be reducing. So first I'll push I. Then I'll say frequency. Now all characters have same frequency. So what I'll do is I'll try to place A, then B, then C, D, E, F, G, H I'll be placing here. So now what will happen is these I will be pushed just one time. I mean one, one, one. So the total there are 6. So this total just 6 pushings are required. And these things are again just one pushes are required. But we have total of how many? 14 characters. So 14 pushes are required here. And this will be pushed in order to display it. You'll have to push, you know, key 2 times. So, but there are 2, so 2 into 2, which is 4. So your answer is no 24 in this case, which is minimum. So what we'll do is first we'll create, character to frequency map, and whichever characters occur more times, those characters will try to place first, which means your character to push vector or mapping will have I as one time pushing, A, B, C, D, E, F, G, and H we have. H will be pushed 2 times. These all will be just pushed 1 time. So right, yeah. Once we have this mapping, we'll iterate over the word we'll see A. So A, how many times you have to push? Just one time. So your answer will be like, let's say, total pushes. So there you'll have to, make sure one time pushing. So you'll have to make plus equals to 1 this way. And let's say when you have encountered H, so in that case it will be 2 times. So I think you guys have understood it's just a frequency thing. Um, let's try to code it up. So first we'll take vector frequency whose size is just 26 because we have lowercase English letters and lowercase English letters are just 24, not more than that. We'll show the frequency. Okay, in the frequency character minus A. For each character, A is basically placed as 0 index, B is at first index, and Z is at 25th index. So once we have this thing, now I'll have pushes vector, like how many, it's basically character to number of push. Okay, let's say it has to push one time that way. Now what I'll try to do is I'll try to fill this push vector. Okay. So what I was doing, maxi initially will be, let's say, 0 and index, let's say, be minus 1. I'll try to find the maximum frequency in this frequency vector. So I'll check if frequency of J is greater than maxi. So my maxi is gonna be frequency of J and index is J. So once I come out of the loop, I'll have to check if this index equals to minus 1, which means we have not found any max element. So which means we don't have any element. So you need to just break. Uh, if you have found the max element, okay, so in that case, what you have to do is you have to do a frequency to character mapping. So we will check if this I is lesser than 8, which means we have 8 slots, like 1, 2, 3, 4, 5, 6, 7, 8. So these 8 slots will be, pushed with, I mean, starting characters will be just pressing so that one time we'll have to press the keys. So your pushes of this index, whatever you have, plus A will be one time. This index you have understood, right? Like frequency of this particular character. Here it is 0 means a character A. So that's why I'm doing index plus A. Else if I is lesser than 16, which means 8 characters are placed, 8 distinct characters are placed across board. Now the ninth distinct character will be placed at position wherein we'll have to push 2 times. So your pushes is gonna be 2 times. Similarly, if I is less than 24, your pushes is gonna be Sorry, it is also A, not B. Three times you'll have to push. Like you had 16 different characters, 8 characters were placed. Again, 8 characters were placed, which requires 2 pushes. And next uh, distinct character if it encounters, so you have to press 3 times in order to display that. At the end, uh, 24 characters are placed. Remaining 2 characters, let's say here, for example, S and C, you'll have to press 4 times to display that character. So it's gonna be 4. So once you come out of the loop, now your total pushes will be 0 initially. You'll have to scan the string, and your total pushes will be pushes of character minus a. Just return the total pushes. Let's try to run it. What is happening here? If index 6 minus 1, I'm just breaking. Mm, Pushes we have 26. Okay, it should be just index because we are doing, mapping of character A to 0 index, character B to 0 index. So it's a good thing only. Only thing is here we have to do minus. Mm, 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 mm. Okay. Okay. Main thing what we have done is I'll tell you. Since in the frequency calculation, this for loop, we are getting the maximum frequency. Once we have got the maximum frequency, we'll have to make sure that maximum frequency is set to 0. Frequency of that index is set to 0. If you don't set, all the time you'll get the same maximum frequency, right? Yeah, let's try to submit. So yeah, it got accepted. And if we try to analyze the time complexity, this is taking O of n. This is taking 26 times of 26, which is constant, and this is taking O of n. So the time complexity is linear, which is O of n. And if you see space complexity, we are using two vectors whose size is 26, which is constant. So space complexity is just O of 1. So yeah, thank you guys for watching the video.